Thank you. So I'm going to be talking about a little tool that we've developed at Sony. It's called DExTer, which is the Debugging Experience Tester. And what that is a suite of tools for viewing, analyzing, and measuring the quality of the user debugging experience. So we've got plenty of good tooling for measuring debug data itself. But what we don't have is tooling to tell us whether that translates to the user actually having a good debugging experience at the end of it. And that's what DExTer aims to solve. And so this is how it does it. So this is a trivial test for DExTer. It's just main calling foo. And when you run it through DExTer, it actually hooks into the debugger, it runs the debugger and steps through the code line by line at source level, and then gives you some information about that. So you can see we're at start at main, we step into foo, it's indented slightly, and then back out to main. And I've put a comment in the test, DexWatchX, that tells DExTer that when it steps to line 3, where that comment is, try and evaluate the expression x. And you can see at the other end of the red line there, it said x has a value of 1. So that's the kind of pretty view of the output. Internally, it's capturing all this data. It's JSON serializable. I call it DextIR. And you can kind of see it's capturing information there, the type, the value, whether it could evaluate it, whether it was optimized away, and so on. So with that sort of information, now we can take it one step further and actually annotate our expectations, encode our expectations into the test. So for example, I've got this on line 10, dex expect watch value. I'm expecting x to always have a value of 1 on line 3 when I step to it. And I'm expecting a few other things, like I never expect to step backwards or step to the same line I was previously on. And so with that, I can then run that through in the debugger and give myself a score, or a penalty. So in this case, I've got a penalty of 0. O0 minus G, so that's perfect. Everything passes as I expect. So whack that up to O2, see what happens. So you can see we've actually now got 2 steps instead of 3. We've done a tail call optimization. So foo is no longer indented because main isn't up the call stack there, but it's still passing according to the expectations that I encoded. So that's fine. We've got a score of 0. And then just to prove what happens if it goes wrong, build it with line tables only. Now we've got this score of 0.5. So we've got this heuristic which decides how bad things are. In this case, we could not even evaluate x at all. It doesn't know what it is. That's pretty bad. It's not as bad in our heuristic as it being able to evaluate x and giving us an incorrect value. That's the debugger lying to us, so that's as worse as you can get. So the supported debuggers on Windows, it's LLDB, Visual Studio 2015, and Visual Studio 2017. On Linux, it's LLDB only at the moment. And I think this will be useful for things like regression testing. So I took builds of Clang from LLVM trunk over the last 12 months, and I ran it on a simple example. It's a little bit more complicated than the previous test. It's just calculating a Fibonacci sequence with a loop, and I'm just looking at the values of the variables in the loop. The example is on my poster. So you can see over the last 12 months, there have actually been changes. So every time that line goes up or down, or every time it goes up, it means the debugging experience has got slightly worse. Every time it goes down, it's got slightly better. So it does change over time. I don't know if anybody pays attention to this, but hopefully with these tests, this tool, we can now pay attention to that. So we can take it one step further. Clang has this cool opt by set limit flag, so we can actually now get pass by pass information on what each pass is doing to the debugging experience. So there's another project ongoing, I think it's a Google Summer of Code project, to use the debugify pass to get similar information. And I think it'll be really cool to compare the two approaches. Hopefully this will be able to prove that the work done using the debugify pass actually then results in a better user debugging experience. And so using that same Fibonacci test, this is what happens as you run passes. So SROA does some initial damage. Now, I should say, each time it gets worse, that doesn't mean that things are getting bad. Things are totally bad, because that might be weighed off against really good optimization, but who knows. So overall, this is running the entire DExTer test suite. These are the passes which do good things and bad things. As you can see, it's actually a really small number of passes which really have any effect. So hopefully with this, we can tune OG, we can improve things. So there we go, time up. Thank you.
Thank you.